So let us look at chemical properties of alkali metals. They occupy leftmost position in periodic table, so they are the most electropositives, or better say, least electronegative elements of periodic table, with electronegativity going down from lithium to cesium. Lithium occupies special position in the group. We'll see that second period elements are usually significantly different from other. Lithium can exhibit high degree of covalent character in its bonding. This covalent character is due to polarizing power in lithium atom associated with high charge density. All other, starting from sodium all the way to cesium, have only ionic compound. With lithium, we have some degree of covalent. Lithium forms usual oxide, Li2O, containing oxide ion when it burns in oxygen. Other group 1 elements form peroxides or superoxides. Lithium reacts with nitrogen, making lithium nitride, and with carbon, lithium carbide. Lithium carbonates, phosphates, and fluorides have very low solubilities in water. All other alkali metal salts have very high solubility in water, practically with no exception. There are a couple of other. Lithium nitrate decomposes to oxide, but not to nitride, and so on. There are visible chemical differences. Now, lithium makes relatively stable alloys with other metals. When alloys of sodium, potassium, and so on are very chemically active and have no interesting physical properties. So a special reaction is reaction lithium with nitrogen, making Li3N, so N3 minus ion, and lithium cations around. This is just a structure. You can watch interesting video on the reactions of alkali metals. Reaction with oxygen. Lithium makes Li2O. Sodium reacts with oxygen, making sodium peroxide Na2O2. And potassium, rubidium, and cesium react, making superoxide KO2, RbO2, CsO2 with O2 minus an ion, very special case. All alkali metals react with water to make metal hydroxide, soluble, and hydrogen gas. Again, please watch very interesting videos showing this violent process. Lithium oxide reacts with water, making lithium hydroxide. Sodium peroxide reacts with water, making sodium hydroxide and hydrogen peroxide. When superoxides react with water, they are making appropriate hydroxides, hydrogen peroxide, and oxygen gas. Sodium peroxide decomposes to make sodium oxide and oxygen. Very interesting reaction of potassium superoxide with CO2 with formation of potassium carbonate and release of oxygen. It's used to make oxygen and collect CO2 in closed volumes when you need to have enough oxygen to breathe for some time and collect CO2 exhaled. All hydroxides of alkali metals reacts with CO2 to make carbonates and water. Solubilities of all sodium, potassium, rubidium, and cesium salts are usually very high. Some lithium salts have low solubility. For example, carbonate, fluoride, relatively low. Solubility of fluoride goes up with lithium to cesium. Solubility of large anions going down to cesium. Very large anions like perchlorate make insoluble salts of rubidium and cesium. Again, practically all salts of sodium are soluble. That's why we may be interested in several compounds that are insoluble. One is hexahydroxystibate, so antimony and 6 OH groups around sodium cation. This compound has low solubility. Another very exotic sodium compound with low solubility is sodium-potassium hexafluoroaluminate. A very beautiful compound that contains sodium, zinc, uranium, uranyl, iron, UO2, 2+, and 9 acetates. This beautiful compound forms insoluble compound of this structure, and you can see it has beautiful fluorescence. It's not radioactivity that you see, it's fluorescence. Potassium, rubidium, and cesium make several insoluble salts. Of them interesting are perchlorates, platinum hexachloride, like this, hexanitrocobaltate, so 6 NO2 groups around cobalt 3+, and then potassium is cantorion or rubidium or cesium. Another very interesting precipitate is potassium bitartrate that crystallizes from wine, so it was known for centuries. Again, beautiful colorless crystals. Tetraphenyl borate is insoluble for potassium, rubidium, and cesium. And if you replace one phenyl by cyano group, only cesium will precipitate. Interesting compounds are made by some cyclic antibiotics, which form stable complexes with potassium ions and facilitate their transport. Synthetic analog of these is so-called crown ether, 6 oxygen atoms surrounding one central atom of potassium. making a stable compound. Otherwise, usually potassium, sodium, rubidium, and cesium do not make stable compounds with any ligands in water or common organic solvents.